Hello, everyone, and welcome to today's live broadcast, The Fundamentals of Freeze Drying, Advice from the Experts on How to Get Started, presented by Megan Zimerman, the Product Manager at Labconco Corporation, and Jenny Sprung, Senior Application Specialist at Labconco Corporation. I'm Michelle Ashton of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is brought to you by LabRoots and sponsored by Labconco. For more information on our sponsor, please visit labconco.com. Now let's get started. I would like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them into the Ask a Question box and click on the Send button. We'll answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, click on the Support tab found at the top right of the presentation window, or report your problem by clicking on the Ask Question box located on the far left of your screen. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located at the top right of the presentation window and follow the process to obtain your credits. I'd like to now introduce our presenters, Megan Zimerman and Jenny Sprung. For a complete biography on our speakers, please visit the Biography tab at the top of your screen. Megan and Jenny, you may now begin your presentations.
Thanks, Michelle, and thanks to everyone for joining us today. We're going to start by discussing a general overview of the freeze drying basics and requirements, followed by how to select the right freeze dryer for your application. Then I'm going to pass things off to Jenny, and she'll talk about developing a protocol, freeze drying challenging samples, and troubleshooting. We're going to start by discussing some common terms you hear when talking about freeze drying. Freeze drying is the process of removing moisture from the frozen product using a vacuum. Another common term is lyophilization, which is just another word for freeze drying. The term is derived from the Greek word solvent loving because these samples are easily rehydrated. This allows for easy resuspension of samples, making it a great process for sample preparation. Sublimation is also a word you'll hear when talking about freeze drying. This is the process in freeze drying in which solvents pass directly from the solid phase to the gas phase, which is what gives freeze-dried samples such great preservation properties. It's important to note the rate at which sublimation occurs is dependent on temperature and pressure. The image displayed here is a phase diagram showing the process of evaporation and sublimation. While evaporation takes a sample from a liquid to a gas, sublimation requires a solid sample that bypasses the liquid phase and passes directly to the vapor phase. When freeze drying, it's important to cool the material below its triple point shown in the diagram. The triple point is the highest temperature at which the solid and liquid phases of the material can coexist. Being below this point ensures that sublimation rather than evaporation occurs. There are 4 important criteria that need to be met in order to freeze dry successfully. The first requirement of freeze drying is that you must have a pre-frozen sample before you start your run. As the vacuum pulls down on the freeze dryer, you may see the sample begin to melt until the appropriate vacuum level is met, so it's important to have a pump that's in good working order. By nature, water molecules from your sample will want to move to the coldest spot in the system. That's why the second requirement of freeze drying is that you have a collector that is 15 to 20 degrees colder than the sample's freezing point in order to trap those vapors coming off the sample. The third requirement for freeze drying is having a deep vacuum with a minimum requirement of 0.002 millibar. This is necessary because the vacuum pump establishes negative pressure, forcing free water molecules that have left the sample by sublimation. The last requirement for freeze drying is having energy in the form of heat. While it might seem counterintuitive, the lyophilization process is essentially a heat transfer process. It's important to note, though, that if you add too much heat to certain samples, you could cause those samples to melt and undergo evaporation. One example of the heat transfer process is with flask freeze drying. As the flask hangs from the manifold, ambient heat from the room temperature is driving the heat transfer process. Because you can't control heat input with this method, it's considered uncontrolled heat. With the use of a tray dryer, you can control heat input into the samples. This is important for samples in the pharmaceutical industry or with the production of samples that require long-term storage. To help develop a freeze drying protocol for methods using controlled heat, you can send your samples off to companies where they will watch the freeze drying process under a microscope. They can then tell you the sample's triple point and what amount of heat input would be good throughout the run. In general, most labs will just guesstimate that heat input, fine-tuning their process to develop an optimized lyophilization run. Next, let's talk through how to select the freeze dryer that's right for your application. One of the first things you'll want to think about is who is using that unit. If the freeze dryer will be used by multiple groups, you'll need to know all of the solvents that could be utilized. You also need to consider who will be in charge of preventative maintenance of the freeze dryer and vacuum pump to keep everything in an optimal working condition. It's critical that you choose the right materials when selecting a freeze dryer. Many solvents used in samples can attack plastic and rubber components, which cause vacuums to leak over time. The use of acids can also damage materials like stainless steel and acrylic. Once you determine the types of solvents that will be used with your freeze dryer, you can apply the following criteria to help you select the right unit. Freeze dryers typically come in collector temperatures of -50, -84, and -105 degrees Celsius. Keep in mind that the collector temperature you select should be 15 to 20 degrees colder than the freezing point of your solvent in order to effectively trap those vapors on the collector coil. You also need to determine the collector size of the freeze dryer. Freeze dryers are described by their ice holding capacity. So if you're looking at a 4.5 liter freeze dryer, that means it can hold 4.5 liters of ice before needing to be defrosted. However, this doesn't mean that you can put 4.5 liters of sample on the freeze dryer at one time. Instead, you would put about half of that volume on there to accommodate all of the vapors that come off of your samples when the run starts. The next thing to determine is the type of vacuum pump that you need. In addition to having the correct vacuum pump specifications, the solvents being used will determine whether you operate with an oil rotary vane pump, a hybrid chemical resistant pump, or the use of a dry scroll pump. There are a variety of ways you can freeze dry your samples, so you also need to consider the method that's best for your application in order to select the correct accessories. Besides selecting the correct type of freeze dryer, you also need to select the right manufacturer. One consideration is how the coil is designed to collect the vapors coming from your sample. With our internal coil design, we're able to provide the coldest possible temperatures and are superior in capturing the solvents coming off the samples compared to an external coil design that is on the outside of the collector chamber. A vacuum control valve is another important feature to have in your freeze dryer. By being able to set the vacuum level, you're able to speed up the runtime when using certain solvents. Other considerations include the types of controls the freeze dryer has, whether GMP requirements need to be met, and if you need the freeze dryer to have pre-freezing capabilities. When it comes to controlling your freeze dryer, the software you have is critical. One consideration is how you plan to access data. With the LyoWorks operating system, you're able to download your data to a USB flash drive or use an Ethernet connection to send your data logs straight to your computer through a one-way connection. Remote notification is also available. You have the ability to configure the types of alerts that can be sent to your phone via email. This is a great feature to have with freeze drying. Since most runs take 24 hours or longer to complete, you won't be left wondering how your samples are processing when you leave the lab for the night. Endpoint detection is another feature to consider if you're Flask freeze drying. It can be difficult to tell when these samples are truly done lyophilizing, and it leads people to ending their runs too soon or running for hours longer than is necessary. The end zone endpoint detection can help you avoid both scenarios by alerting you when your samples have achieved the level of dryness you set at the start of the run. Now I'm going to pass things over to Jenny so she can discuss developing a protocol.
Great, thanks, Megan. Megan discussed how to choose a lyophilizer. Now we're going to talk about developing the protocol. There are 3 steps in the freeze dry process. Pre-freezing is your most important step. If the samples aren't frozen solid, meltback will occur. Knowing your sample's freezing point is extremely important. Primary drying will remove 92 to 93% of the moisture from the sample and will be the longest step of the process. Again, you want to make sure your samples don't melt during this time. Finally, secondary drying will remove the residual moisture from your samples and takes about 1/3 to 1/2 the time as primary drying. There are different ways to pre-freeze. Stub freezing limits the surface area and is not the preferred method to pre-freeze samples in flasks. Stub freezing can put stress on a flask, especially during dynamic temperature changes. This method is best for serum vials on a tray dryer. Okay. Slant freezing is a preferred method of freeze drying over stub freezing in flasks. Slant freezing provides a large surface area and decreases the freeze-dry runtime. Shell freezing is the optimal method for freeze drying in flasks as it maximizes the surface area to volume ratio by spreading the sample throughout the entire vessel. This gives you optimal surface area and it optimizes the heat input to the sample, providing a large contact area between the sample and the flask. By controlling the rate of pre-freezing, you can change the size of your ice crystals. Slower pre-freezing results in larger crystals which freeze dry faster. It's best to know your samples and how they respond to the freeze dry process. Now we'll move on to primary drying. This step will be the longest and remove the majority of the moisture from the sample. During this step, adding heat is favorable to the process. On shelf, you have to control how much heat is added. The shelf temperature should be set to just below the sample's freezing point to prevent melting. On ports, the heat will come in the form of temperature from your room. If your freeze dryer is sitting near a window or other heat source, melting can occur. By controlling your vacuum pressure, you can also speed up the lyo process. The typical recommendation is 0.2 millibars for most samples. The ability to run primary drying at higher product temperatures greatly reduces drying time by creating a larger pressure differential between the vapor pressure over ice in the product and the pressure at the condenser. Each 1 degree increment increase in product temperature can decrease primary drying by 13%. Secondary drying removes the final 7 to 8% of moisture that primary drying did not remove. It adds additional heat to drive the freeze-dry process. Secondary drying works best using controlled heat on product shelves, but can be done in flasks by adding additional insulation to warm the flask. The temperature can be as high as 50 degrees C during secondary drying because the free ice is now removed. Maintaining the same vacuum pressure is advised as lower vacuum levels will not speed up the process. Samples can be stoppered under vacuum or nitrogen for long-term storage after the freeze-dry process is complete. Now we'll discuss the best conditions for the room that the freeze dryer will be placed in. Room temperature should be around 22 degrees C, and the room should not be too small. Remember, the freeze dryer and the pump will create heat on their own. Keep the unit away from windows and heat vents. Both can cause melting during the process by warming the sample above the eutectic point. If the freezer is located far away from the freeze dryer, make sure you insulate the samples during the walk or drive to the freeze dryer to prevent melting before the samples are placed on the freeze dryer. Look for liquid surrounding samples to determine if meltback occurred. Some samples may require additives if they are not freeze drying correctly or giving the outcome desired. These include bulking agents, thermal stabilizers, lyoprotectants, and pH adjusters. If your lab requires GMP for your freeze dryer, there are a couple things to keep in mind. GMP regulations neither approve nor prohibit specific equipment for use in manufacturing. Firms are afforded the flexibility to select equipment that best satisfies their particular needs, and they are free to modify standard equipment designs to best suit their process. Manufacturers can provide the materials of construction, a QA test report for the specific freeze dryer that was ordered, manuals, videos, literature, dimensions, etc., to help you run your unit. An IQ/OQ is typically offered by the manufacturer to be done by the customer. However, PQ must be done by an outside consulting firm. Not all samples are a good fit for a lyophilizer. These next few slides will talk about the samples and how to overcome their challenges. Some samples don't give a nice powder at the end of the run. Terp-butyl is one that results in a gummy end product. Alcohols are difficult to freeze dry because of the low eutectic temperature and lack of temperature differential between the sample and the collector temperature. They must be diluted to 10% or less and use a -105 freeze dryer for successful freeze drying. DMSO is known to attack rubber and plastic components, which are a big part of any freeze dryer. Because of this, these parts may need to be replaced over time to prevent any vacuum leaks. Sugars and salts lower the eutectic temperature, which require a cascade-type collector. They can also bypass the collector and get into the pump as particles. An inline HEPA filter will protect the pump from these particles. Soil samples are typically aqueous-based. However, the particles can migrate into the vacuum pump and again get into the oil and cause damage to the pump. An inline HEPA filter is also recommended when doing soil samples. If your samples are fruit and vegetables, the best way is to homogenize them, or at the very least, poke holes in the skin to allow a way for moisture to leave the sample. This is true if you're running animal samples as well. Freeze drying is an art, and things may go wrong during the process. Most of the issues can be overcome by taking a few steps. If your samples are not staying frozen, make sure you're using the correct collector for your samples. Remember, a temperature differential of 15 to 20 degrees is required. Small samples tend to melt faster than larger samples. Insulating them will help. If there are alcohols in the samples, again, make sure you dilute them and make sure you're using a -105-degree freeze dryer. Vacuum pressure should not be too high. If you can't get a good vacuum, it may be time for an oil change. As the samples dry, they become powdery and could get pulled out under a deep vacuum. Using filter paper or parafilm will help prevent this. And remember, colder is not always better when it comes to freeze drying. If the samples are taking too long to dry, check the shelf temperature and make sure it's close to the sample's freezing point and not lower. Surface area will help speed up the process. If the sample is too thick, it's going to take a long time for the moisture in the bottom of the sample to move through the already dried upper portion. Also, make sure you have enough space between the flask and the rubber top. This is especially important if you're putting test tubes inside of a flask. If there's not enough space between the top of the test tube and the rubber top, it will prevent vapor flow. Poor vacuum can sometimes be fixed with an oil change if one has not been done for a while. Check your oil after each run to make sure it's not too cloudy or dirty. You can also check the valves and gaskets for cracks or tears that might cause a leak. If samples are not sealing correctly, make sure they are evenly spaced over the shelf prior to stoppering those samples. Many things can cause the final product to look different between runs. Change in room temperature, temperature or purity of the solvents, and the % of the active ingredient in the samples can cause these differences. This is very common in the freeze-dry process. pH shifts are common with buffers. Okay, we're ready to take any questions that you may have.
Thank you, Megan and Jen, for your informative presentation. We will now start the Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many questions as we have time for. All right, let's go ahead and get started. Okay, first question is, at what temperature must the sample be cooled before lyophilization?
Well, it really depends on what the... Sorry, Megan, go ahead.
That's a really great question, but as Jenny was starting to say, it just depends on what the sample is made up of. So, we say that choosing a collector for a freeze dryer, you need to have the sample temperature differential between 15 and 20 degrees colder than the sample's freezing point. And you can kind of use the same logic for when figuring out what temperature you need to freeze your samples at. So if you're doing an aqueous-based sample, anything below freezing is typically fine. A lot of people have -40 freeze dryers. That doesn't mean that you can't use a -80 or colder. It just isn't necessary. So don't feel like you have to go colder in order to completely freeze your sample.
Great, thank you. All right, next question. What is the suggested room temperature to run Labconco freeze dryer?
Yeah, so that's a really great question as well, because sometimes, we get people that call us and say they're having trouble with their freeze dryer, their samples melting, all of that kind of stuff. And a lot of times it has to do with the heat load inside of the room. So I will say that when we test our freeze dryers at Labconco before we send them out to customers, we do all of our quality control testing in a temperature-controlled room at 72 degrees. And so really anywhere between 68 and 72 is an ideal temperature to run your freeze dryer.
Thank you. And what is the name of the accessory that indicates when Flask freeze drying is complete?
That would be our end zone endpoint detection system. And if you have any additional questions about that, feel free to reach out to us. But like we kind of covered in the presentation, it's really just the use of vacuum sensors measuring the vacuum level inside of the sample compared to a reference port on the manifold.
Thank you. And does it matter how I pre-freeze my samples?
Pre-freezing is actually the most important step of the process. You want to get as much surface area as you possibly can. So shell freezing in flasks is going to be the highest recommendation. If you cannot shell freeze, then slant freezing is going to be the next best thing.
Great, thank you. Now, would you recommend lyophilizing products in the 96 well plates? And if so, how would you be able to control the exposure once the door is opened?
Well, so 96 well plates can be tricky to freeze dry because there's a couple things. First of all, the samples are typically very, very small. So if they do melt during the run, they could potentially pop out. Also, if they're very powdery, once you do vent the vacuum, you could lose some of the powdered sample, the end sample. So if you can somehow cover the microplates with either parafilm or a filter paper and then poke holes in it, that's going to really help you with the whole process and prevent loss of sample.
Great, thank you. Now this question says, you said 0.2 glycerol vacuum is required. Does this mean that the minimum 0.2 vacuum required to start freeze drying process? I hope that makes sense.
Well, with our freeze dryers, you can choose what vacuum set point you want. So it really is going to be dependent on what your sample is. In general, we do recommend the 0.2 millibar. It will help speed up your lyophilization process. So I think that's what they were asking. If not, I can follow up with an email just to make sure that we got that one covered.
Perfect, thank you. All right, next question. How can I seal under vacuum without buying a stoppering tray dryer?
We offer
oh, go ahead, Jenny.
Nope. Okay, what I was going to say is we offer two different options. So if you don't want to invest in a stoppering tray dryer or a triad unit, you can either look at a clear manually stoppered chamber. What that allows you to do is it's a clear chamber with two shelves inside of it. You put your vials on the shelves, and then you manually crank the stoppering mechanism to raise those shelves up and stopper. Or we also have what's called a mini stoppering chamber, which can be hooked onto ports of the freeze dryer. I believe you can run up to 8 vials at a time, and you would just stopper under vacuum. But this would be great if you just had a port type freeze dryer but needed to stopper just a few.
Now, what are the suggested containers, glass beakers, plastic bags like Ziplocs, etc., to freeze dry samples?
Sorry, Michelle, can you repeat that one more time?
Sure. Let me pull it back up. Okay, what are the suggested containers to freeze dry samples? For example, glass beakers, plastic bags, tubes, etc.
Okay. Yeah, so it really just depends on what your end goal is. You know, if you're trying to prepare something for long-term storage, or you're working with things like pharmaceutical research, a lot of people want to stopper under vacuum, and so they'll use either glass vials or ampule pods that they can flame seal under a vacuum. If this is just meant as a sample prep step for you in a series of testing, then you could use something like Flask freeze drying or trays. But anything that's just going to allow that vacuum to flow freely. So something like a plastic bag, unless it's sitting open, you may not get that vapor transfer that you would if you were using a material that had like a permeable membrane. So just something to keep in mind when you're selecting sample containers.
That's great. We have so many wonderful questions coming in from the audience. We'll just take a couple more. And this one says, what is the best freeze dryer to use for someone starting up a small agro-processing production?
Well, the best one really is dependent on the solvents that you're going to be using. So before you buy a freeze dryer, what we always recommend is knowing who's going to be using it, what solvents, or is it just aqueous that will be run on the unit. And then you also need to know how many liters of moisture you want to remove at a time. So before you decide on what you want, make sure you have those questions answered. Labconco actually has a questionnaire that can walk you through each and every item that we need to know about. And so we can send that to you prior to making a recommendation.
Thank you. Okay, and our last question today is, if the samples contain a little of organic acid, is it okay for lyophilization?
Yeah, so with organic acids, the only thing that you really want to make sure of is that you've got the right type of freeze dryer. So we do offer PTFE coating for our collector chambers and coils, but you also need to be mindful of the drying accessory that you use as well. So with organic acids, you want to stay away from acrylic because it will etch and crack over time. And you know, lid materials, you likely want to go more with a glass lid. So when you're selecting your freeze dry equipment, just reach out to us and we can help walk you through the types of materials that you need to look for to make sure that you have a freeze dryer that will last.
Thank you. And I want to thank the audience for their great questions. Any of these questions that we did not have time for today will be addressed by our speakers via the contact information you provided at the time of registration. Thank you again, Megan and Jenny. Do you have any final comments for our audience before we go today?
Well, we really appreciate everybody joining us today. And, like Michelle said, we'll be reaching out. So we look forward to speaking with you guys. I do just want to say, though, that we do have, for those who are looking to get started on their work quickly, reach out to us. We have a limited quantity of select freeze dryers available for immediate shipping. So we are ready to help you get started. And I think that's it for me. Jenny, did you have anything else?
Nope, that's all I have. But we will be reaching out to everyone shortly.
Thank you again, Megan and Jenny, for your time today and your research. I'd like to thank LabRoots and our sponsor, Labconco, for underwriting today's educational webcast. Until next time, goodbye.